Hello everyone, I am Dr. P. Chandra, Associate Professor in the Department of Computer Science and Engineering, Aditya University. Let's talk about the today's topic, data structure and its types. Coming to the learning outcomes of this lecture, at the end of this lecture, student will be able to distinguish between data and information with suitable examples. Illustrate the concept, importance and applications of the data structures. Recognize different types of data structures and their real world cases. So, these are the learning outcomes of this lecture. Prior to the data structure, let's see about data versus information. You can see what is data. Raw facts or figures or symbols that do not have a meaning by themselves. And if you see the example on the screen, that is 85, 90, 78. What are all these values called? We don't know, because it doesn't have units and measurements. And if you see like this, information, the processed and organized data that provides meaning and helps in decision making. Example, you see the average student scores 85%. The same 85 represented as 85% here, that is a raw fact is processed to become an information. That means data is called a raw fact and some processing happens, then the data becomes the information here. And let's see another instance of the data versus information. And data, that is 32 degrees centigrade, 70% humidity, 15 kilometer per hour wind speed. So, these are the raw facts what we collected, but what sort of information we can gain from this is, so we need to do some processing on it. That is, okay, 70% humidity, 32%, 32 degrees centigrade temperature. It is clearly indicating that it is a hot and humid day. This is an information what we processed from this data or raw fact. And you so carry water bottle and avoid staying in the sun for too long is the decision what we made here. Is the decision what we made here. Here raw numbers become useful information for daily decisions. Here raw numbers means 32 degrees centigrade, 70% humidity, 15 kilometer per hour wind speed are called the raw numbers. By processing them, we got the information that it is a hot and humid day. With that, what decision you have made ourselves is carrying a water bottle and avoiding staying in the sun for long time is the decisions what we made here. That is the correlation between data and information. So data and information what you have seen. Now, it's the time to learn about the data structures. Before going to see the data structures, we must have some fundamental information why we have moved towards the data structure or how the journey has been commenced. The journey initiated with runtime values. I think you all have done a C programming in your earlier classes. Usually the runtime values or the values are known only when the program is running. Okay. What are the limitations of it? Value is temporary, cannot be stored and further usage is not found, and errors found late. Why errors found late is because the program doesn't know what kind of input is given by the user here. In such cases, error cannot be identified. And now let's see the probing questions. Can we know the value before the program starts? Especially in the case of runtime values? No. What if the user enters the unexpected data? You are expecting the user to enter integer, but then the user entered character data type. So that is a mismatch. How can the program plan memory in advance? You are expected the user to enter only 2 bytes of data, but the user entered 20 bytes of data. And can the compiler verify correctness early? That is before starting of the program, in terms of runtime values? Can the compiler? Absolutely no. What if errors only happen during the execution? So all these are the problems with respect to the compile time value, runtime values. To solve that, compile time values has arrived, and that is the solution for us now. Compile time values. So we will declare those values inside the program called as constants. We will declare the values that directly in the program. Example called pass mark is equals to 35. The value of pi, that is prominently predefined, that is 3.14. Here, what are the limitations here means? For example, what if you want to change the pass mark here? It is defined as a constant. Throughout the program, the pass mark is 35. So we cannot change the program. That is the limitation here. That is fixed values. Fixed values. That is the limitation. To overcome this, what should we do? And these are the probing questions. What if values must change during the execution? One example, the pass mark. Can compile time values handle user input? What if data changes every second? Here it is a pass mark. If at all you are going to record a cricket score, that means value gets changed every time, there constant values or the compile time values are not suitable. Can fixed values support dynamic applications? That's what we discussed now. Cricket score is one of the examples of the dynamic applications where fixed values are not supported. What is the solution for this? Is variables. Variables could be the solution for this. Let's see what is a variable. Variables can change during the program execution. That is int mark equal to 85, mark equal to 90, mark equal to 78. Initially it is 85, next it has become 90, next it has become 78. The value gets changed. So this is the concept lied in variables. Can store only one value. Difficult to manage multiple values. Okay, and too many variables become messy. Here mark equal to 85 overlapped with 90 later, 90 overlapped with 78 later. What is the probing questions here? What if we need to store 1000 scores? Do I need to create 1000 variables? How the program looks like if I do so? It creates a lot of mess in the program, right? So to avoid that, what should we do? We need to need more storage values together. The possible solution for this is arrays. Let's see. Int marks is equals to 85, 90, 78, 88, 95. Not even one mark. We are going to store 1, 2, 3, 4, 5 marks under one variable name called marks. This is how an advanced version where the problems of the variables are covered here. Okay. Now, what I would like to store few more values to the same marks. Let us say in the beginning I got satisfied with the 5 values, but later I would like to add 8 values. That is 3 more values need to be added now. Is this possible? Not possible with respect to the arrays. That is the primary limitation of the arrays. That is fixed size in many programming languages. So what to do? To overcome this, we need to have a smarter storage organization, data structures, where we can store data efficiently, access the data efficiently, we can operate on the data efficiently. So finally, fast searching, efficient memory usage, dynamic size, handles complex relationships also can be made possible through the data structures. And you can see the title of this heading, the journey of data, why we move forward. We have started with runtime values, identified some limitations there, compile time values, still limitations are there, variables, still limitations are there, so on, arrays followed by data structures. And moreover, now we are in the era of latest data structures also, and we can say that every new concept was created to overcome the limitations of the previous one only. This is what we should notice here. Now, let's see the definitions of data structures by various authors. A data structure is a collection of data elements whose organization is characterized by accessing operations and associated algorithms proposed by Satra Sahani in the year 1976. And another author, that is Jeffrey D. Ullman, in the year 1983 proposed data structures are the ways of organizing data in memory so that algorithms can process them efficiently. I hope both definitions are similar in nature. And if you see the another definition proposed by S. Lipps in the year 1986, a data structure is a specialized format for organizing, processing, retrieving and storing data. And recently in 2013 also, one author proposed a data structure is a particular way of organizing and storing data in a computer so that it can be accessed and modified efficiently. With all these formal definitions proposed by various authors, we can simply say that a data structure is a smart way of organizing and storing data so that it can be used efficiently with the help of algorithms. As we are confident enough in learning the definition of the data structures, we should learn classification of the data structure also. The primary classification of the data structures lies with primitive data structures and non-primitive data structures. Primitive are a simpler one, what we have seen in executing a basic programming language. And moreover, primitive data structures can also be called as data types. For example, integer data type, character data type, float data type, boolean data type. So, whatever the data types you see in any programming languages can be considered as primitive data structures. And while non-primitive data structures are broadly classified as linear data structures and non-linear data structures. Linear, array, linked list, stack, queue. Non-linear data structure is a tree and graphs. Of course, the list continues further, but this is the basic classification what we are discussing. Coming to the brief about arrays, elements are stored in a contiguous memory locations and accessed using an index. This is the beautiful property of an array. And moreover, in linear data structures, data elements are arranged in a sequential order. The words sequential order and contiguous memory locations correlate each other. The elements are 10, 20, 30, 40, 50, 60 are stored in an array now, holding an index value at 0, 1, 2, 3, 4, 5. And there are no gaps between the elements, right? That is called contiguous memory location and sequential order of storage. And accessed using an index. Here I can easily tell that the index 5 holds the element 60. The index 3 holds the element 40. Like that, whatever the index value I would like to retrieve, based on that index value, the data will be retrieved accordingly. And the primary limitation of arrays is fixed size. If at all you want to increase the size, it is not possible here. And to overcome that limitation, linked lists were developed. That is, elements or nodes are stored in a non-contiguous memory locations and linked using pointers. That is, a head pointer will be there, and this 10 is called a data element, and this dot is called address, pointing to the next element, that is 20. What is the next element? 30, and this address points to the next element called 30, and this address points to the next element called 40. Finally, Once we conclude that the nodes are no more nodes to be inserted, then the last address is treated as null. Okay. Here, wherever you want to insert 50, you can insert 50. If at all you want to delete 30, that is also easily possible in linked list. And then here another limitation of the linked list is that what if accessing should be very fast? A little bit accessing slow is in linked list. So that's why we have gone to the stacks now. Elements are added and removed from the same end called top, which basically follows the principle of last in first out, LIFO. Okay. And there exist two different operations, that is push and pop. Initially this will be empty, and then 20 will be inserted, and then 30 will be inserted, and then 40 will be inserted. Okay. This is the order of insertion: 10, 20, 30, 40. And if you see the order of deletion, 40, 30, 20, 10. So this is called last inserted element will come first out. That is, last inserted is 40. The first out element is also 40. This is the principle of stack, that is the last in first out. And if you see the queue, the elements are added at rear end and removed from the front end. So where the limitation of the stack is only insertion and deletion possible at only one end, whereas in queues insertion at one end, deletion at another end, suitably insertion at rear end and removed from the front end. Usually you see queue systems everywhere, right? While purchasing tickets or while giving your attendance in a biometric system, everywhere we used to follow queue method, that is called first in first out. The one who entered into the queue, upon finishing the particular task, that person will be come out first. Now, non-linear data structures, these are especially to hold complex relationships, especially hierarchical relationship. A parent-child relationship is especially held by the non-linear data structures, and these elements are not arranged in a sequential order. Each element can be connected to multiple other elements. There are two popular non-linear data structures, that is tree and a graph. A tree is a hierarchical data structure in which elements are connected in a parent-child relationship. A graph is a non-linear data structure, consists of a set of nodes or vertices connected by edges. Here, how many vertices are there? Is 5 vertices are there. Edges 1, 2, 3, 4, 5, 6 edges are there. And here, how many nodes are there? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7 nodes are there. How many edges are there? 1, 2, 3, 4, 5, 6 edges are there. Okay. If I wish to draw any other tree, for example, A, B, C, here it contains 3 vertices or 3 nodes and 2 edges. So with this, I want to tell the definition of the tree, that a graph with n vertices and n minus 1 edges is called a tree. If a graph contains 5 vertices and 6 edges, to make it as a tree, we should make it as a 5 vertices and 4 edges. Then it satisfies the property of a tree. So, before tree, graph is there. Graph is a cyclic data structure, whereas tree is a non-cyclic data structures. Let's move on to the summary. Data refers to the raw facts and figures, while information is processed and meaningful data decisions will be there. That's what we have seen. That is 32 degrees centigrade, 70% humidity. It clearly indicates it is a hot day and humid day also. Based on that, what decisions we have taken? That is, you need to carry a water bottle and to stay away from the sunlight. Data structures help organize and store data efficiently in computer systems. And you might see hard disk partitioned into different drives. Each drive contains folders contains files. All these are neatly organized, right? For that organization in computer systems, that is called a tree organization, where tree contains hierarchical relationship. And the common types of data structures we have seen is arrays, linked list, stacks, queues, trees, and graphs. And of course, the list continues further. This is enough. Data structures improve program performance, data management, and problem solving efficiency. The real the real world applications such as banking, healthcare, social media, navigation system, e-commerce platforms, and more, whatnot. The list continues where the data structure is available. Thank you.